Good morning, students. Good morning. So all of you are here. Or still we have to wait. Some more students has to come, or only these many students? Okay, anyway. So before starting with the class, I think this will be my first class for you people. I can't see your face or you people face, but you can see me. So myself, Dr. Raghavendra Hegde Katte. Okay, Raghavendra Hegde Katte. So basically, I belongs to North Canada. All of you might have seen Gokarna, Sirsi, right? So that side I belongs to. Now, I'll be teaching chemistry at Learners B College. At the same time, I'll be visiting Mahajanas where I'll be working for PG Center. Then at Yuvrajas also I'll be teaching. So this is about my introduction. Fine. So in Mysore I'm here still since from 2002. That means 18 years. So that I can tell that I am a Mysorean also. Fine. So one thing I will make it very clear. Any doubts when I will be teaching something, any doubts, no need to hesitate. You can type your questions because here you cannot speak, right? So in a regular class I used to tell that you can ask the questions. Now I can tell you can type the questions. Okay na? So in between also you can type the questions. I will be watching whatever messages will be there. So any doubts. So what I mean to tell you is you should not leave the class with having some doubts in your mind. It should be clear. Fine? So no need to hesitate. Okay na? So in that case, shall I start with the class? Okay. Still busy with good morning messages. Okay. In that case, I will start with the class. Fine. Yes, sir. You people have typed. Okay, nice. Now, as you people know, we are going to start with the periodic classification of elements. 1 minute. So, periodic classification of elements. Classification of elements. Now, I am bit poor with respect to handwriting on the board. If you are not understanding any word, let me know. Okay. So today's topic which we are going to discuss here is periodic classification of elements. Right? Now, all of you know that first topic is basic concepts of chemistry. Then comes the atomic structure. Then comes the periodic classification of elements. After that we have the chemical bond. Right? Now your syllabus is designed so beautifully in such a way that they have given the topics based on their importance. All the basic topics which are fundamentals for chemistry. You can understand chemistry if you dominate these topics. So they have arranged in such a way that whatever these 4 topics I told, basic concepts of chemistry, then atomic structure, then periodic classification of elements and chemical bonding. Along with that, in organic chemistry we have only 2 chapters in first PU, but when it go for second PU we have lots of chapters. Many chapters are there. So when it comes to part 2 first PU, we have 2 organic chemistry topic. One is basic concepts of organic chemistry, then hydrocarbons. Now, according to me, if you dominate these 6 chapters, no, you have to learn all the chapters, no doubt. If you dominate these 6 chapters, then definitely chemistry will be easy for you. Because in my experience in PU field, I have seen that when I was a student, I used to think that chemistry is very easy. Because for me, chemistry I am very much interested. Chemistry and biology. Fine? Mathematics. So that's where all the fingers cannot be same. So same way, I used to think that chemistry will be easy. What is that? So I came to PU field, I was teaching, then I came to know that for students, chemistry is also one of the tough subject. I was surprised. Then I came to know that it's proved, it was justified that yes, all the fingers are all not same. That means all the humans cannot be same. So each one will be having their own interest. So now, to dominate the chemistry subject, anyway, we cannot be 100% in anything. We have to be we will be learning, no doubt. But to understand, to master the subject, especially chemistry, so these are the 6 chapters you have to learn thoroughly. Whatever is there in your NCERT book, word by word, you should be very thorough. Fine? So then you can understand other chapters also. Otherwise, what will happen? It will be like you are constructing a house without proper foundation. And all of us will know, without proper foundation, naturally a building will going to collapse. It cannot be stable. So try to understand all these basic topics. Then only you can appreciate chemistry as a subject. Fine? All of you have understood? Because it's our interest which will make to learn the subject thoroughly, to understand the concept. To get the interest, you should be understanding. If you ask me to watch a movie, with the language which I don't know, then I will not appreciate that particular movie. But if you ask me to watch a movie which I know, then definitely I am going to appreciate. That's where understanding the concepts are very important. Fine? Now, when it comes to periodic classification of elements, in the name itself it is there. Before starting with the class, in the name itself, first we have to clear the title of that particular topic. Right? Now we have periodic. That's where, what do you mean by periodic? Periodic means regular. Right? There is a regularity, there is a repetition. Every interval, there is something which is happening common. So that is the meaning of the periodic. Right? So periodic classification, all of us we know, where we are going to categorize the things. So that's where we have the classification. Now, elements, all of you have studied already in basic concepts of chemistry and in atomic structure. What we mean by elements? Elements are nothing but pure form of a molecule or an atom. So that's where we have the elements. In this case, we are focusing on the atoms. So that's why periodic classification of element means this is how the elements are arranged in a particular manner where we can see there is a repetition in the common properties of those elements. That's where periodic stands for. Now the question here is why we have to classify, right? Naturally, any one of us will raise the question, okay sir, we will learn the chemistry, but why the hell we have to classify the elements? In botany, taxonomy, oh headache. Zoology, once again headache. Everywhere classification will be a problem for us, sir. Straight away, why we can't learn? So that's where the question comes. Why we have to classify the elements? That's quite natural. It's a quite natural question by any of the human beings. Now, if you observe, if you see the Mysore city, all of us will know that Mysore is a pretty good large city. Now, if you observe, they have classified into different areas. We have Gokulam, Vantikopal is there, VV Mohalla is there, Yadavgiri is there, right? So that's how a city has been categorized into different areas. Why we have to do that one? Why not as a Mysore city, as one city? It will be difficult to locate the place, right? And some of the areas they will have their own pin codes also. So that's how it will be easy for communication. Now I can tell I am staying at Gokulam. If I tell I am staying at Mysore, now the question will be where? So that's where why we have to classify. Since a number of elements which have been discovered has been increased, the number has been increased. Now it is very much required. We have to classify the elements. We have to arrange them in a particular manner based on their properties. That's where classification of element is very much required. Whether I have reached you, whether we have got the answer why we have to classify the elements, yes, that's where we have to classify the elements. Right? Now, when it comes to who did it first, next question is why we have to classify. That is done. After that, who did this one? Who is that person who initiated? So that one by one we are going to discuss. Naturally, for anything, contribution will be not by one person. There will be involvement of many of the people. Right? Yes, Achyuta. So we'll come to that one. Okay? So that's where it's not one person who is involved. It will be like first it will be done by one person, then it will be further polished by or further developed by another person. Like that we have the contributions by the people, group of people who has worked at a different era. Right? So that's where we have now modern periodic table. That one anyway, we are going to discuss it in detail. Fine? Now, if I talk about where, once again, that's why I feel bit bad that nowhere when we are studying the history of periodic classification, we will not see an Indian chemist. That is one thing. Okay? But otherwise, there is involvement of German chemists, English chemists are there, then Soviet Union chemists are there who has contributed these things for the development of the periodic classification of elements. Therefore, these two I will be discussing in detail, one by one, step by step we are going to discuss in detail. Right? Now, which, right? So which era or which is that year when it has been developed? That will be the question. Right? So which year this has been developed? We are in 2020. Right? Now we know that there is a presence of almost 118 elements in 2020. At present we know that we have almost 118 elements. In that 94 elements are natural elements which are naturally present, but rest of the elements are man-made. Rest of the elements are man-made, that can be due to some nuclear reactions. Right? So that's where we have almost around 118 elements. But in the beginning, there were no 118 elements naturally. It started from small number of elements. So it started somewhere around 1835, approximate year I am telling. So 1825 it started, then 1829 one contribution came, then it was well established in 1835, so then it went up to 1865, further another law came. Anyway, so who, where, which, all together I am going to discuss, categorize. Fine? All of you have understood? Any doubts? In the same way, how it has been done? Next question will be, how they have done, sir? What I mean to tell you is, if I take all these things, you will get the answer how it has been done. They are interlinked with each other. They are interlinked with each other. Right? So that's where we are going to have the periodic classification of elements. If you get the answer for all these things, you are going to have the understanding of the periodic classification of the elements. All of you have understood, which is very much required for the chemistry. If you want to understand the chemistry as a subject, we have to understand these things. You have to get the answer for these things. All of you have understood? If I see the board perspective, because as a student, I know ಎಲ್ಲ ಹೇಳಿದ್ರಿ ಸರ್, ಬಟ್ ಈ ಟಾಪಿಕ್ ಯಾಕೆ ಕಲಿಬೇಕು? ಕ್ವಶನ್ ಸಮ್ ಸ್ಟೂಡೆಂಟ್ ದೇ ವಿಲ್ ಆಸ್ಕ್, why we have to learn this topic? Not because to understand the concept from exam point of view. Why we have to learn this topic? How much? Right? So how much questions will come from this topic? What is the weightage? Right? So what is the weightage for this particular topic? All these questions will be there. But please remember, if you are raising these questions for that perspective, you are not going to master the subject. Please understand. Why question should be raised? In interest to learn the topic, not for the exam point of view. How? It has to be raised the question to learn the topic, not for the exam point of view. All these questions should be raised to understand the concept. Right? So you read the topic not for the exam perspective, you read the topic for to gain the knowledge, to understand the concept. Right? Naturally, it will be easy for your exam also. But anyway, when it comes to weightage, with respect to board exam point of view, from periodic classification of elements, you can expect around 4 to 5 marks question. For board exam, you can expect around 4 to 5 marks question. Fine? So that's where with respect to board exam. But when it comes to competitive exams, right? So where if you go with number of questions, 1 or 2 questions you can expect from this particular topic. Then you may feel, sir, only 1 or 2 questions. Why the hell then we have to read this particular topic? That's what I told. When it comes to NEET exam, if it is 2 questions, there is a pretty good amount of importance has been given. Right? That is one thing. But above that, this is the basic topic. If you understand this one properly, then you are going to master the chemistry a bit. Not only this topic I am telling, totally we have 7 chapters in our first PU. All those 7 chapters, if you learn properly, definitely we are going to appreciate chemistry as a subject. Because all of us, we know that any movie we will appreciate a lot. But when it comes to subject, then we will be thinking that one, whether it's a good subject, right? So that's where I mean to tell with respect to board exam point of view, this is the weightage which is given for periodic classification of elements. Right? So any doubts up to here? In that case, shall I continue with the class if you don't have any doubts? Okay? Now, we will start with the class. Now, I will be answering those questions. Who, right? When, where, and which year. That one we are going to discuss in detail. That's how your topic has been classified. It has been arranged. So, this topic, periodic classification, has been arranged based on that only. Right? So, where? First, we will be talking about the history. Right? History means, I am not talking about social studies. History means how this classification of element has been developed. Right? Who has developed, which year it has been done, where it has been done. Everything comes under history. How it has been done. So, right? So, now, once you know the history of this periodic classification of element, then you should be talking about periodic law. Modern periodic law and Mendeleev's periodic law. 2 are there. So then we have to discuss about periodic law. What is that? What does that mean by periodic law? Right? So that we are going to discuss. Once it has been done, then we have to go with IUPAC nomenclature, or naming the element which is having atomic number greater than 1. Okay, which is 100, greater than 100, which is having atomic number greater than 100. Right? So once it is done, we are going to discuss about different blocks in the periodic table. In the modern periodic table, different blocks. Anyway, we are going to discuss that one, that we can have the different blocks in the periodic table. S block, P block, D block and F block. So that's what we are going to discuss about the features of those elements briefly in the periodic table. So once it is done, how they have been arranged, right, based on their property as a overall. Here it is specific, right? So how they have been arranged, on what basis they have been arranged, what will be the relation of atomic size, right? Electronegativity, electropositivity, metallic character, non-metallic character. That's what we are going to learn. So if you go with the exam point of view, you can expect 1 mark question from this particular part, right? You can expect 1 mark question from this particular part. You can expect 1 mark question from this particular part. Even 1 mark question here also. But here, how they have been arranged, based on the atomic radius, based on the metallic character, non-metallic character. That's where it can be asked for 3 marks. In this block, it can be asked for 3 marks. Fine? Anyway, whenever I will be discussing those topics, I am going to tell which is important and all. You can note it down, no doubt, no problem. Fine? All of you have understood? So this is how periodic classification of elements have been categorized. That particular topic, different concepts are there, which we are going to discuss one by one. Okay? So as I told, first we are going to discuss about history. First we are going to discuss about the history. Some of you were already writing about the name of the person, right? So that is Dobereiner, right? So we have the Johann Dobereiner, who is the one who first started arranging the elements, who gave first thought. Yes, I can arrange these elements, I can categorize these elements. He is the one who first gave that particular idea, who came first with that particular idea, where he proposed law of triads or triads. He proposed the law of triads, right? So that's where we have the Johann Dobereiner, who is the one who first gave that particular idea. All of you have understood? So hagadre. Now when I am talking about triads, please remember, whichever concept if you want to understand, first you should understand the word, because in the word meaning itself that concept will be hidden. Fine? See, for example, law of triads. Law, we know that what you mean by law, right? Now, triads. Triads means 3. Something related to 3. So that's what Dobereiner observed. When he arranged the element, he observed that we can have three groups of elements. Okay? So for example, he observed that if I take lithium, sodium, then potassium. He observed that, for example, in his law of triads, I am giving the example lithium, sodium, potassium. Now atomic weight. If I go with the atomic weight, okay. So earlier, because we were not talking about atomic number, they used to talk about atomic weight. So atomic weight, it will be somewhere around 7. When it comes to sodium, it will be somewhere around 23. And when it comes to potassium, somewhere around 39. Right? Now, what he observed here is sodium will be having atomic weight which will be average of first and third element. Right? So what I mean to tell here is 39 plus 7 divided by 2. It will be 23. It will be 23. That's what he observed. Then he proposed law of triads. He proposed law of triads. Yes, Shri Vidya. So that's where here we can observe sodium, which is the middle element. It is having average mass of the first and third element. So that is nothing but law of triads. Then we can define or we can put forward that particular law, right? We can give a statement about that particular law which tells that it is anything. It is first proposed by Bromine, no doubt. It tells that the weight or atomic weight of the middle element, someone has already written, very good. So atomic weight of the middle element will be average mass of the first and third element. Okay, average mass of the first and third element. And please remember earlier, now modern periodic table we know it is based on the atomic number, but earlier it was based on atomic weight. They were not talking about atomic number, they were talking about atomic weight. Okay, now, so which was put forwarded somewhere around 1829. It was happened somewhere around 1829. Remember about law of triads. Okay, now. So yes, Shri Vidya and Achyuta, both of you are correct. Fine. That's why we can define the law of triads. That is the contribution of Bromine, who is a German chemist. Bromine. Okay, na? So he is a German chemist. Fine. In that case, we will move to the next one. This was the first initiation. Next one by Newland's theory, that is related to Alexander Newland. That is related to Alexander Newland. Okay. Now, what he did, what is that? What he has done? He gave the law of octaves. He gave the law of octaves. Now, all of us will know octet rule. No, not octet rule. Achyutas. Okay, now. So, octet rule, then it comes to chemical bonding. It is called as law of octaves. Okay, Newland's theory of law of octaves, not octet rule. Octet rule talks about chemical bond, which we are going to discuss in the chemical bonding. Fine. So, that's where we have the law of octaves, which was put forwarded in 1865, or somewhere around 1865, right? So, what is this law tells? What is that Newland's theory? One mark question you can expect where you have to define. So, it tells that when you arrange the element in the increasing order of their atomic weight, when you arrange the element in the increasing order of their atomic weight, first element and the eighth element will be having common properties. First element and the eighth element will have the common properties. That's where octaves. Octa stands for 8. So octaves, law of octaves. That's why that word octaves. In earlier case, triads. That because 3. Here octaves. That is because 8. Fine, all of you have understood? Now, what he did is, he arranged the element lithium, beryllium, boron, then carbon, nitrogen, oxygen, fluorine, right? 1, 2, 3, 4, 5, 6, 7. Inert gas not discussed. Then comes the sodium. Then comes the sodium. Now magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Then comes the potassium. Then comes the calcium. He arranged up to calcium. He arranged up to calcium. To be surprised, he observed that if I consider this one as the first element, eighth element will be 1, 2, 3, 4, 5, 6, 7, 8. This will be the eighth element. So first and eighth element, they have the common properties. Right? So lithium and sodium, now we know they are in the same group. In modern periodic table also, they are in the respective groups only, no doubt. That's why we should appreciate the Newland's theory. Right? So if I consider beryllium as the one element, then what will be the eighth element? It will be magnesium. Naturally, beryllium, magnesium, now also they are in the same group. Right? Any element you pick it up, respective eighth element will be of same category. For example, if I take fluorine as the one element, then which will be the eighth element? 1, 2, 3, 4, 5, 6, 7, 8. Chlorine will be the eighth element. Right? So what I mean to tell here is, whichever element if you pick, and from there if you go up to eighth element, it will be of same properties. Even now they have been put it into same group. Anyway, group period we are going to discuss it later, but for time being you can see they are of same properties. Right? But only thing here is Newland was able to arrange the element up to calcium only. Right? So that might be one of the drawback, but that's where we have to appreciate. We have to appreciate him because so beautifully arranged. He has arranged so beautifully. Right? So then that's where we have the law of octaves. Please remember in your exam, if they ask for law of triads for 2 marks, you have to define, then one example you should give, which I gave it as lithium, sodium, potassium. If you don't remember the atomic weight, that is absolutely fine. So don't write the wrong atomic weights. Okay? So now, when it comes to atomic weight, so first and third element, it will be average atomic weight of these two will be the atomic weight of the middle element. That's what you can write. So when it comes to lithium, sodium, potassium, lithium, potassium, they are having atomic weight, average atomic weight of these two will be the atomic weight of sodium. That's what you can mention. If you don't remember the atomic weight, no need to write. Same when it comes to law of octaves. So no need to write all those things. You can pick lithium and sodium as another example, eighth element. Then you can tell that they have the similar property. 1 minute. Sorry. So whether I am clear? So what I mean to tell you, what is the drawback of Newland's theory? It's up to calcium, not beyond that. Okay? So it's not beyond that. He was able to do up to calcium. Beyond that, it will not follow exactly this category. It will not follow. Fine? So that's where we have the Newland's theory of law of octaves. Fine? Any doubts? Any doubts? So Achyuta, calcium, strontium, barium, but it's not uniform, which we can see here. It's not uniform as up to calcium. Okay, now? Yes, there are some thing which is applicable, but not uniform. Only up to calcium it is exactly uniform. Exactly it will follow the law of octaves. Okay? Now we will move to next one. That is chlorine, bromine, iodine. Yes, you can give, but More up to iodine, it was there, but you can give, if you remember, you can give, even that can be included. I have taken only first group element. You can take that one also as example. That belongs to the Berliner triads only. Chlorine, bromine and iodine, no doubt. Fine. So now we will come to one of the person who has contributed a lot to the classification of element. Who has contributed a lot towards the classification of the element. That is Mendeleev. That is Mendeleev. Now when it comes to Mendeleev, he is also considered as father of periodic classification of elements or father of periodic table. Due to his contribution, he is considered as father of periodic table. Father of periodic table. Right? Because he is the one who gave first idea, who arranged these elements with respect to increase in their atomic weight. So therefore he will be considered as father of periodic table. Okay? Mendeleev, yes, he was from Russia. Okay? So he was from Russia. 1 minute. Who is considered as father of periodic table. Okay? Now, normally they will ask, explain the Mendeleev's periodic law. Okay, someone has already written. Okay? So that tells that physical and chemical property of the elements. Physical and chemical properties of the elements are depending on the atomic weight. Physical and chemical property of the elements are depending on their atomic weight. Right? So there is a periodicity in the property of physical and chemical property which depends on the atomic weight. As I told, what is that periodicity? Right? In a college, first period, then fourth period. So like that periods will be there, right? So that means every day there will be a something which will be common. First period will be chemistry and fourth period will be biology. Like that, every day it will be there. There is a periodicity. Right? So same logic is applicable here. But according to Mendeleev's periodic law, he tells that physical and chemical properties of the element, periodicity in the physical and chemical properties of the elements are depending on the atomic weight. Some students, they will write atomic number, then we should give 0 marks. It is atomic weight. Repeatedly I am telling. Fine? So earlier they were not talking about atomic number, they were talking about atomic weight. Now, if I want to tell what is that Mendeleev's contribution. So one is, he is the one who gave first periodic law. What is that? It tells that physical and chemical properties of the elements, periodicity in the physical and chemical properties of the elements will be depending on the atomic weight. That is the first thing, his contribution. Then he gave Mendeleev's periodic table. He gave one particular table where he arranged the elements. And he was so particular, so accurate that he left some of the gaps. He left some of the gaps. That means, for example, we have Eka aluminium. That means next to aluminium, he left the gap. Because that time it was not discovered. So he left the gap. Below the aluminium, nothing he has written. Because that time it was not discovered. But he predicted what can be the atomic mass of that element. What type of compound it can form. So that's where Eka aluminium. Now we know that Eka aluminium belongs to anyone. Eka aluminium is nothing but Now we know that it is gallium. Now we know that it is gallium. Below the aluminium we have the gallium. That is group 13 element. Aluminium is group 13. Boron family I am talking about. Aluminium, gallium. Eka aluminium is nothing but gallium, which is next to the aluminium. Aluminium will be somewhere here. Next to that eka aluminium. Now we know that that is gallium. Right? Same way we have the eka silicon. Eka silicon. That means which comes after the silicon. We are talking about group 14 elements. We are talking about group 14 elements. Right? So now we know that eka silicon is nothing but germanium. Another material which will be used for the semiconductors. Limitation of elements were not placed according to its properties and no defined space for hydrogen. Okay. So I will come to that. So that's where he left some of the gaps. Now those gaps he called it as, in these two are the example. You can be expecting 1 mark question. That is eka aluminium, eka silicon. So eka aluminium is nothing but gallium. Eka silicon is nothing but germanium. Fine. So that's where we have the naming of the elements. Fine. So yes, Ashish. Oh, people writing lots and lots of messages, good. But I am really sorry. At once I cannot see all the messages. Otherwise even class will get disturbed. But you should be typing the messages, no doubt. Okay, na? So that's where we have the gallium and germanium, which are next to aluminium, which is next to the silicon. That's where we should appreciate the Mendeleev, who was so accurate in his guessing. It's a guesswork. It's not practically done. He was guessing, yes, this can be the atomic weight, right? And it was justifiable now, because we know that whatever atomic mass he gave for eka aluminium, same thing is for gallium. Whatever he gave for eka silicon, same thing is for germanium. And even they will form similar type of oxides, compounds. Even he predicted that one also. Which type of oxide it will form, which type of oxide it will form, and he gave the general formula. And now we know that that is absolutely correct, right? But only thing here is, when it comes to Mendeleev's classification of element, first and foremost thing here is, it was depending on the atomic weight. He put forward a periodic law based on the atomic weight. That was the major drawback, because now we know atomic weight is not going to have much impact on the chemical properties. It is the atomic number. That is the major drawback of the Mendeleev's periodic classification and Mendeleev's periodic law. That is one thing. Second thing here is, there were lots and lots of space in between. In that way, we may not be making Mendeleev's responsible for that, but that gap was created because those many elements were not discovered, right? So that is one thing. Second thing here is, he gave not much space for the more elements to be included. That can be another drawback. He didn't give much space because he was not knowing. We cannot blame him. He was not knowing. He didn't give much space for the inclusion of the more elements. Fine. Then he didn't talk about what will be the hydrogen position. Right? Now we know. Anyway, when we are talking about modern periodic law, modern periodic table, I am going to talk about hydrogen also, no doubt. But when it comes to Mendeleev's classification of element, he didn't bother about the position of hydrogen. Right? And lastly, very important one is, he didn't discuss about isotopes. He didn't discuss about the isotopes of the element. Okay? So that's where we have the limitations of Mendeleev's periodic classification. All of you have understood? So 1 minute, atomic masses were not accordingly arranged, so people could not decide. Okay, okay, but you can give broad limitations. Okay, so first is based on atomic weight, so which is the major drawback. Next, lots and lots of spaces were there in between the elements while arranging with increasing order of atomic weights, right? Then position of hydrogen he didn't discuss. Then last one you can talk about isotopes. You can talk about the isotopes. All of you have understood? That's where we have the Mendeleevs. Now when it comes to Mendeleevs, he is considered as father of periodic table because based on his studies, later modern periodic table was designed. Based on his studies only, modern periodic table has been designed. But before that, there was a person called as Mosley. Okay, so don't go with Kannada word Mosale. Some people they will tell Mosale. So don't go with Kannada meaning. Okay, so that's why we have the Mosley. Okay, another thing. We have Arthur, another person who gave along with Mendeleev, who is also contributed but independently. Mendeleev and Arthur, they contributed independently. Okay, now, but still, even Arthur was also having contribution in making the periodic table. Fine, but we'll consider Mendeleev's. Now comes the Mosley, Henry Mosley. He is the one first who gave the idea about the relation between periodicity of the properties and atomic number. He is the one who came with the periodicity of the properties of the elements. He is the one, Mosley. Henry Mosley is the one who first gave idea about the periodicity in the properties of the element with respect to atomic number, not with atomic mass. He did a very simple experiment where he took X-rays, and all of us will know X-ray is one of the electromagnetic radiation, where electromagnetic radiation will be arised due to interchange or change in the position of the electrons or inertial electrons. So that's where we have the X-rays. It is one of the electromagnetic radiation which has been originated due to change in the arrangement of the inertial electrons, innermost electrons. So that's where he took frequency of X-rays. What is the square root of nu here? It is nothing but frequency of X-ray or X-radiation. Fine? So frequency of X-radiation. So that's what he took it on y-axis. Fine? And on x-axis he gave with the atomic number. He went with the atomic number, not atomic weight. I will tell. He came with atomic number, and to his surprise, he got a straight line. He got a straight line. So what it indicates? Please remember, in any graph, if you are getting a straight line where two characters are related to each other, definitely if you are getting a straight line, it indicates that they are directly related to each other. They are directly related to each other at any point. They are dependent on each other. They are directly related to each other. Right? So that's what we can conclude since he has got the straight line. So that's where Mosley's contribution. Okay? So ಹಾಗಾದ್ರೆ when I am talking about X radiation, why we can correlate that one with atomic number? Because it's an electromagnetic radiation. X-ray is nothing but the electromagnetic radiation. So anything this is coming out with one particular frequency, that will be related to how that innermost electrons will be arranged. So based on that, these radiations will be occurring. High energetic radiation, right? So therefore it will be having pretty high frequency, because frequency and energy, they are directly related to each other. Fine. Now based on that, he found that whenever he plotted the graph, that is square root of frequency of X radiation to the atomic number, he got a straight line. But when he did the same thing with respect to atomic mass, he didn't got the straight line. He didn't got the straight line. And do they have the flexibility to add more new element in this table? Oh, okay. I will come to that. Okay, now? So that's where we have the Moseley's contribution, who gave the first idea that there can be a relation between periodicity with respect to properties of the elements and atomic number. Okay? Fine. This is the major contribution. From here comes the modern periodic law. Mendel's periodic law we have already discussed. From this point of view, we are going to talk about modern periodic law. What is that modern periodic law? So modern periodic law is nothing but, that's why this was done in, I think, 1913. Okay? So we have already entered into 20th century from 19th century. That's where we have the 1913. That's where we came with some idea where there is a periodicity of the property of the element will be related to atomic number, not to the atomic mass. So that's where Henry Moseley's contribution. Fine. Now from here onwards, it's well established that atomic number is the one which is going to decide the property of the element. So that's where we have the modern periodic law. Modern periodic law and modern periodic table. Modern periodic table. That's where we have the modern periodic law and modern periodic table. What is that modern periodic law? If you have studied about Mendel's periodic law, now we have to change only one particular word, that is mass has to be replaced by the number. That's where the definition is done. So what I mean to tell you is modern periodic law is nothing but periodicity in the property of the element, that is related to chemical and physical properties of the element, is related to the atomic number. It is related to the atomic number. But when it comes to Mendel's periodic law, it was related to atomic mass. So therefore I told all the words will be same. Only difference will be you have to replace that mass with the number. Then comes the modern periodic law. So repeatedly I am telling this one because some students, they will do the mistake. In exam they will ask, explain or define the modern periodic law. Then they will write about, and at the end they will write atomic weight. Right? When they will come out of the exam hall, how much for chemistry? They will tell, hey, out of what? It was very easy. But when they see then they will get the result, it will not be out of what for chemistry. Because 1 mark is gone. Because that one word which has made you to get the low marks. That is atomic number here, atomic mass or atomic weight with respect to Mendel's periodic. So don't get confused. Fine? So that's why we have the modern periodic. Now, when it comes to modern periodic table, now it is also called as a long form of periodic table. It is also called as long form of periodic table. So what is that long form of periodic table? That is because one thing, it is much longer than that of the Mendel's periodic table, no doubt. It is much longer than that of the Mendel's periodic table. Why it is much longer than Mendeleev's periodic table, sir? That is because to accommodate the new element which will be discovered. They have given option to accommodate the new elements whenever it will be discovered. All of you have understood? So that's where we have the modern periodic table, which is also called as long form of periodic table. Now, who is the father of periodic table? Mendeleev. Still it is Mendeleev only who will be considered as father of periodic table, because he is the one who first arranged the element, but it was based on atomic weight. But still, contribution is from Mendeleev's only. Fine? When I am talking about the modern periodic table, which is also called as long form of periodic table, we will be having words like groups and periods. Now, since atomic structure has been done, all of us will know what we mean by atomic number. Right? What do you mean by atomic number? Atomic number is nothing but total number of protons. Atomic number is nothing but total number of protons present in the nucleus. That's where we have the atomic number. Then you might be having the question, sir, protons are present inside the nucleus, then how they are going to decide the property of the element? Right? That will be the question. Now naturally, if you take any atom, I am not talking about the ions, any atom if you take, number of protons will be equal to number of electrons. Right? Number of protons will be equal to the number of electrons. So I can tell that atomic number is the total number of electrons present in a neutral atom. Right? So atomic number is the total number of electrons present in a neutral atom. That word is important. Neutral atom. Okay? Because when it comes to ions, number of electron, number of proton, it will vary. Right? Say for example, if I take sodium, atomic number is 11. It will be having 11 proton and 11 electron. Therefore, it does not have any charge. Now, if I take sodium, atomic number is 11 only, but it is having a charge. Sodium ion, Na plus. Atomic number is 11 only, right? But what is happening? So there will be presence of 11 proton, but only 10 electrons. Now number of proton and electrons are not equal. There is a change. So therefore, if I want to define with respect to electron and atomic number, then you should mention that in a neutral atom. That one word you should be entering. Otherwise, you can define with respect to number of electron also. But you should be mentioning that in a neutral atom. Fine? So that's where we have the atomic number, which is going to decide the chemical and physical properties of the element. Right? Now when it comes to groups, groups are nothing but, they are the vertical columns. They are the vertical columns. Groups are nothing but vertical columns, which is found in the modern periodic table. Right? So they are nothing but vertical columns. Now when it comes to periods, they are nothing but horizontal rows. Horizontal rows. So that's where we have the groups and periods in the modern periodic table. Okay? Fine? So that's where we have the groups and periods. What are groups? These are the vertical columns present in the periodic table. And what are periods? These are the horizontal rows present in the periodic table. Now, vertical, all of us we know that vertical means which will be standing erected. Right? So that's, that's where we have the vertical. Horizontal means which will be parallel to the floor. Right? So that is horizontal. So that means when I am talking about groups, they are vertical columns. When I am talking about the periods, they are horizontal rows. Fine? All of you have understood? Any doubt? Okay? So in that case, anyway, today's this one I will stop here. But before leaving the class, I will brief about what and all we have discussed today. Right? So first thing we have discussed about history. Right? So in the history of periodic table or periodic classification of elements, we have discussed about law of triads, then law of octaves, right? Then we have discussed about Mendeleev's periodic law, right? Then we have discussed about Moseley's contribution, that is related to frequency of X-ray and atomic number. Then we have discussed about modern periodic law. Then briefly I have discussed about modern periodic table. No, not completed. So I have started with modern periodic table. So this is what we have discussed. Fine. So that's where law of triads, law of octaves, Mendeleev's periodic law, Moseley's contribution, modern periodic law as one set which comes under history. Then comes the modern periodic table. So in this case you can expect 1 mark question or 2 marks. For example, define the law of triads. If it is for 2 marks, if you define it, then you will get only 1 mark. Definition with one example, then you are going to get 2 marks. Same logic is applicable for law of octaves also. Then they can ask, define Mendeleev's periodic law, 1 mark question. Or they can ask, define modern periodic law, 1 mark question. Fine? So that's what from this part. So when it comes to modern periodic table, we were discussing about periods and groups. Anyway, in tomorrow's class, we are going to discuss it in detail. Fine. So any doubts up to here in today's class? Any doubts, you can type it there. Okay. So, okay. Thank you. So whether all of you have understood? Students will not have any doubts, only under 2 conditions. One is when they have not understood anything. Right? They have not understood anything. I have to ask, I have not understood anything. Or in second case, when they have understood everything. Which category my students belongs to? To which category? Okay, fine. Achyuta, he has made it clear. No doubts, it's clear he has done. Okay, fine. In that case, if you have understood everything, very good. And I appreciate you people are sending lots and lots of messages when classes were going on. That shows that you are involved in the class. Very good. Keep it up. Okay, na? Thank you. Thank you very much. Okay? Take care.